Hi guys, this is Dan from Pacific Tech Center, and today we're going to begin our programming adventures by explaining a simple state machine, how it works, and how it can be used to define the behavior of a device and how we react to it. So the first thing in a state machine is, starting. Right, you got to start somewhere. Well, what do? When we start, we need to read in a configuration because by default, the program's not going to know what type of devices you have, how many you have, and how to react to it. So, reading in the configuration from a file that we create, or as we're starting off with, it's all going to be in the source code. And then once we have the configuration, we're going to initialize it based on whatever the configuration is, and then we're going to go in an endless loop. So in this endless loop, we're going to go through every single device defined, and then we're going to perform the different states. The first thing, of course, is initialization for that particular device, and then we check to see if we're done with the current state. We find out what the next state is, and if it's time to complete the current state and move on to the next one, we're going to perform the task needed to close that current state and then move to the next state. And then after that, then we complete the task and move on to the next state. A real easy way to understand a static state machine is an answering machine. Well, I'm not sure if anyone uses answering machines anymore, but you do have voicemail capabilities on your phone, so it'll be pretty much the same. Here, we're going to initialize the machine, basically make sure the device is in its init state, waiting for phone calls, capable of waiting for phone calls, and then we're going to wait for a phone call. And then once someone calls, we're going to answer the machine. We're going to play a message, make a beep sound, record a message from the caller, and then we're going to hang up the call and then wait for the next person. So here are the routines that are defined to perform this task. And then here's the static state. It never changes. It's always this. What do? We initialize the device. We wait for a phone call. If we have any errors, we're going to perform error handling functions, whatever that is. And then if everything was normal, we would wait for the call, answer the call, play a message, right? Beep, and then record, and then hang up. Of course, there's a lot of details for each state, but that's not what we're covering right now. Right now, we're just kind of covering the overall concept of a state machine. Well, I think we should actually take this more to something that's more relevant to what we're going to be working on. So let's move on to an LED light. In an LED light, we're going to, for this example, we're just going to blink. And from here, what we need to do, we need to initialize the pin on the GPIO, tell it that it's a output only pin. Then we're going to turn on the light by bringing it high. And then after a delay, we're going to turn off the pin and then delay again, and then basically turn it off and on. So we're going to go into this constant endless loop. You can see the behavior here, right? Initialize, turn it on, delay, turn it off, then delay, do an additional delay, and start over. You notice right here, I don't re-initialize it. The only time I initialize it is the first time. From there on out, it's basically just going to loop through steps 1, 2, and 3. The only time I re-initialize is if there's an error. I don't know what the error would be, so let's try to re-initialize it and see what happens. And we could end up in an endless loop, but this is a very simple state machine that we're defining here, and we're not going to get too complicated. So you can of course, go along with me on the source code, or you can just watch the video. I did take the initial example from the website wiringpi.com, And most of the code is going to be written based on the functions that you have there. Of course, we are writing everything from scratch, but we are taking examples from this. This is the GitHub site that you can go to, and the current video that you're looking at is within the simple state. There are two examples in there. There's blink LED LED.c and state1.c. And let's move on to what we're looking at. So let's go ahead and look at the we're going to go ahead and look at the Raspberry Pi, and you can see how I have it connected. And we have, based on this example, let me show you what we're looking at here. We'll go to here. And you see in here that we have the 0 is GPIO 17. And they do explain it somewhere on the website. But from that, I was able to take that and show you on here that we'll go here. And I wanted to show you the actual layout of the board. So here is the pinouts for the GPIO. And what I did is I connected the GPIO 17, which is right here. I have that connected to the positive anode, if you will, of the LED. And then I have right next to it is the ground. So that was really easy to set up. And if I show you the camera again, you will see that right here is GPIO 17, and right next to it is ground. I have black and orange. So black is the ground, orange is the pinout. And then over here, I have a 220 ohm resistor connected to the power, going to the anode of the LED, and then ground going to that part. So let's go to the code. I'll bring you back to the Raspberry Pi, and we'll move over here to the keyboard and monitor for this, and let's show you what I have. So within the Pacific Tech Center GitHub site, I have a subdirectory called Simple State. And I have first the example that they gave on the website. Very small program. All it is initializing the system. And you see here, aborting if it can't initialize. And then initializing the port to configure it as an output. And then here's an endless loop where it's going to turn on the pin, wait a second, turn it off, and of course, I just realized I have it reversed here. It's actually turning it off first and then turning it on. I'll correct that at a later time. Anyway, this was just an example based on the website. Now, let's go and show the state machine. First, well actually, first let's go over the makefile. So if you go over the makefile, you can see here it's very simple. I'm defining how to create the executable. So here's Blink LED. I'm compiling it over here, and then I'm linking it over here. And these are the libraries that I'm using. for state 1, I'm doing the same thing, right? And then clean up. So in the end, when I upload the code and stuff, I'm not going to upload the executable code or the object code. I'm only going to upload the source code. So I will clean this very often. Anyway, let's go to the state machine. I first had to define the header information. So you can see here, I'm using GPIO 17, which is on the wired Pi is pin 0. These are the different state machines I have. We have initialize the LED light, which is basically tell it's an output port. Turn it on, which is basically, well, not basically, it is turning it high. And then the end is going to delay for a second. It's going to turn it low. It's going to delay a second. And then I have it delay another half a second before it goes back to turning it on and off again. So it's an endless loop. Here I define the structure for the state machine. So first we have the actual state number. Then we have the friendly name that we're going to display, the start function, and the end function. So you see, I don't expect to return, or at this point even give a parameter because we're only dealing with one device. We will change this structure as we go. Then the behavior. Well, what's the behavior? That's telling it, what you do and what step. So, if you initialize it, what do you do after that? It's shown in the graph that I showed you at the beginning of this video. Now, let's go over to the C code itself. Okay, so now that we have gone over the code, let's go ahead and watch what happens when we do the, run it. So the first thing we want to do is let's make executable. I showed you earlier that we're going to do the example first, and then we're going to do the simple state version. So I'll show you one more time. Oops. This is the example code. And what is it going to do? It's going to turn the light on and then off. Let's go ahead and correct this real quick because on is actually high. And we'll change this to low. Go ahead and save that. And then make it. And let's run it and we can see what happens. You can see it goes off and on. Okay, let's double check the state machine. And you see here, I did find a correction. This was wrong earlier, now it's correct. And what do we have here? We have the definition of what we are going to keep track of for this device. And we only have one device, so it's pretty simple to initialize. This routine right here, mark start, that's going to allow us to determine the elapsed time. And then here is the function that will check to see if the number of seconds have elapsed and also the number of milliseconds. The get time function is actually based on nanoseconds, but it's easier for me to work within milliseconds instead. So you see down here, milliseconds are 1,000 per second, and nanoseconds are 1 billion per second. So in order to convert the millisecond to nanoseconds, I just multiply it by a million. That way, 500 milliseconds is half a second. And if first I check the seconds, and then if it matches, then I'm going to check the milliseconds. If the seconds has exceeded my check, there's no further check I have to do at that point. We've exceeded the elapsed time. So it's basically two conditions where I can return a true and then anything else is false. Here I'm going to initialize the pin to output, and then there's nothing else to do, so I immediately return to the next state, which is to turn the pin high to turn it on, mark the start time, and then check for 1 second, see if a second has elapsed or not. If it has, then I set the next state. If not, then continue waiting for the time to elapse. Here I'm turning off the LED light by turning it low, marking the time, and waiting for 1 second to elapse. And then the delay. The only thing I'm really doing is marking the time and checking to see if half a second has elapsed here. You know, it's just something to do so we had an additional state. That's the only reason why I added that there in reality. Here we're initializing the wiring pi library. If it fails, we go ahead and abort. If it succeeds, then we tell it that we're going to work with real time. And we're going to set the current and next state to unknown, just for initialization purposes. Here, if it's in unknown, I'm going to immediately configure it to initialization, call the startup routine, well, of course, print the friendly name, and then call it the startup routine, perform its tasks, which, as you remember, all it did was make it output. And hold on just a second, I'll turn that off. And then the next thing to do would be to check to see if the state is done. If it is, then we're going ahead and run the next state. And this, so at this point, the function said it's done and it performed its closing tasks. And now we have the next state. We're going to print it out, and then we're going to execute it. If we want to do some things in the background when the machine is doing nothing, we can put it here. But we have some other things we're going to be doing as well in further versions of the state machine, which is more using multi-thread. Anyway, very simple state machine. As you can see, there's a lot more code here than there was for the example, but it accomplishes the same thing. And the whole point of this is so it can handle a whole bunch of devices at the same time, kind of a multi-process single thread, or a multi-function single threaded routine. Allows you to control everything from one central process. Let's go ahead and make it, which we already did earlier, and then run the state machine, and you can see that it's pretty much the same thing that you saw with the example. One thing you can note is that the display is not exactly as real time as the LED itself. So the LED is actually more accurate. You'll see it turning off and on before you see it displayed on the screen. Anyway, there's both showing the example of how to do a single threaded, single function routine, which is in the example, and the state machine. Our next versions that we will have will, of course, handle multiple devices, and we'll get into that on the next video. Great. Well, I hope you enjoyed this first version of the simple state machine. We, of course, are going to get more complicated and handle more devices than LEDs. But first, we're going to do multiple LEDs, then we'll perform other tasks. And at some point, we'll have a full program that handles all different types of devices that you can use in electronics. And hopefully you enjoyed the ride. So if you liked the video, please give it a thumbs up and subscribe if you haven't already subscribed. And I'd like to say aloha and mahalo for watching.